You think you understand light. You watch the sun rise over the horizon, spilling gold across the fields. You kindle a candle against the evening darkness. You walk beneath the noonday sky and feel the warmth on your face, and you believe, with the certainty of a thing too obvious to question, that you perceive something simple, something pure, white light, the original light, the fundamental thing from which all else derives. You are wrong, not slightly wrong, not wrong in some technical detail that matters only to scholars. You are wrong in the most basic way it is possible to be wrong about light. And this error has shaped how men have understood nature for over 2,000 years. Consider what you believe. You believe that white light is elemental, that it comes to us directly from the sun in its original, uncorrupted form. You believe that colours arise when this pure light is somehow modified, stained, or corrupted by the materials it encounters. Pass white light through coloured glass, and the glass imposes its colour upon the light. Pass it through water droplets, and you get a rainbow, the water transforming white into the spectrum of hues. This is what Aristotle believed. This is what the medieval scholars believed. This is what natural philosophers believed, right up until careful experiment proved them mistaken. And this is what you, in all likelihood, believe right now. But here is the question that should trouble you. What evidence supports this belief? When did you test it? When did anyone test it? The answer, for 2 millennia, was never. Men observed that white light came from the sun and concluded it must be original. Men observed that colours appeared after light passed through glass or water and concluded the medium must create them. The reasoning proceeded from observation to assumption to certainty without ever pausing for demonstration. This is not a failure of intelligence. The philosophers who held this view were brilliant men. This is a failure of method. Watch the rainbow form after a storm. The colours arc across the sky: red, orange, yellow, green, blue, violet, appearing to emerge from the grey light and disappearing as the bow fades. Is it not obvious that the water droplets have created these colours? Is it not manifest that white light has been transformed? It seems obvious. And that is precisely the problem. The rainbow demonstrates only that colours appear under certain conditions. It does not demonstrate that colours are created by those conditions. The appearance is ambiguous. 2 entirely different explanations account for it equally well. Either the water creates colours that did not exist, or the water separates colours that were already present but hidden. Ordinary observation cannot distinguish between these possibilities, and so men chose the explanation that seemed most natural, most intuitive, most aligned with what they already believed. They chose wrong. Here is the principle you must grasp. What appears simple to the eye may be compound in nature. Your perception reports uniformity where composition is concealed. The eye cannot analyze the light it receives, it can only summarize. And summaries, however useful, are not truths. Imagine you had lived your entire life in a chamber illuminated only by red light. Every surface would appear as shades of that single colour, what we would call red, pink, maroon, brown. Would you suspect that your illumination was merely one component of a vastly richer mixture you had never perceived? You would not. The eye reports what it receives. It cannot report what it lacks. Now consider, what might ordinary sunlight lack that you have never perceived? Or rather, what might it contain that you have never distinguished? The senses summarize. They do not analyze. This is their nature. When you look at a white page, you see uniformity. When you look at the sun's light streaming through a window, you see simplicity. But seeing is not knowing. The eye blends what is distinct, hides what is complex, presents as elemental what is in fact composed. This is not malice, it is limitation. And limitation, unrecognized, becomes deception. 2,000 years of learned men trusted appearance where they should have questioned it. They built elaborate theories on foundations of assumption. They confirmed their beliefs daily with observations that proved nothing, because confirmation is cheap when the test cannot distinguish truth from error. The question now presses, if the assumption of purity is groundless, what maintains it? Why does error persist across generations despite the brilliance of those who hold it? The answer lies not in what we believe, but in how we form beliefs about nature itself. The staining theory of light survived for 2,000 years. Consider what that means. Generation after generation of scholars, men who could calculate the motions of planets, men who could reason with geometric precision, men whose intellects we still admire, accepted without question that white light was pure and colours were corruptions. They observed prisms producing rainbows, saw coloured glass casting coloured shadows, watched the natural world display its chromatic variety, and concluded in every case that media transformed light from its original purity into derivative colours. Why did no one question this? The answer is not stupidity. The answer is that ordinary observation could not distinguish the truth from the error. Both theories, that prisms create colour and that prisms reveal colour, predicted exactly the same phenomena. The staining theory was confirmed daily by anyone who looked through coloured glass, but so was the composition theory, had anyone known to look for it. The observations were ambiguous, only the interpretations differed. And without a test that could discriminate, belief settled where assumption directed it. Consider a merchant who weighs his goods on a scale he has never calibrated. For years, perhaps decades, his measurements have been consistent. Every time he weighs a pound of flour, the scale shows the same reading. Every time he weighs a bolt of cloth, the numbers agree. He trusts his scale because it agrees with itself. But agreement is not accuracy. Consistency is not truth. If the scale is wrong, if it reads heavy by a tenth or light by a fifth, then every measurement is wrong. And the consistency proves nothing except that the same error repeats. Without a true standard against which to test, the merchant cannot know whether his readings represent reality or merely represent his scale's particular form of distortion. This is precisely the situation natural philosophy faced with light. The staining theory predicted that prisms would produce colours from white light, and prisms did produce colours from white light. The theory was confirmed, but the composition theory predicted exactly the same thing, that prisms would display colours hidden within white light. Both explanations fit the observed facts. Neither was tested against the other. Confirmation that cannot distinguish truth from falsehood is worthless. A theory that accounts for every observation while ruling out nothing has explained nothing. The deeper problem is this. Once an assumption becomes established, subsequent observations are interpreted through its lens. The rainbow proves that light can be transformed. Therefore, transformation is assumed in all similar cases. The coloured shadow demonstrates that glass stains light. Therefore, staining is taken as fact. Each new phenomenon, rather than testing the theory, merely extends it. The error compounds across generations, building elaborate structures on foundations that were never examined. This is the comfort of consistency. Men prefer coherent error to the discomfort of uncertainty. Questioning the staining theory meant questioning Aristotle, questioning the medieval authorities, questioning centuries of received wisdom. It meant admitting that something everyone knew might be wrong. Few would accept that burden without compelling reason. But here is the matter. Comfort is not a guide to truth. Coherence is not a standard of reality. Nature is indifferent to human preference for tidy explanations. What was needed was not more observation, but a different kind of observation, an experiment whose outcome would differ depending on which theory was correct. What was needed was a test that could discriminate, not merely confirm. Imagine you must determine whether a sealed box contains one object or many. Without opening it, you shake the box and hear a single sound. Does this prove singularity? Consider. Multiple objects might move together, producing one sound, or they might be packed so tightly they cannot move at all, producing silence even if numerous. The sound, or its absence, confirms neither hypothesis. The test cannot discriminate. This is what natural philosophy required. Not another observation that both theories could claim, but an experimentum crucis, a crucial trial that would force nature to declare herself. A test whose outcome would be different depending on which explanation was true. If colour is created by prisms, then passing coloured light through additional prisms should create additional changes. Each prism should modify what the previous prism produced, staining it further, shifting it toward new hues. But if colour is intrinsic to rays, if white light is already a mixture and prisms merely separate its components, then coloured light cannot be further changed by prisms. A red ray, once isolated, should remain red through any number of prisms because its colour is not imposed from outside but carried within. One prism tells you nothing decisive. It produces colours, but it cannot tell you whether it creates them or reveals them. Two prisms change everything. The second prism is the question. The coloured ray's response is the answer. If the ray changes, the staining theory stands. If the ray remains unchanged, the composition theory is proven and 2,000 years of assumption collapse. The method here is everything. Observation alone accumulated ambiguous data. Only experiment designed to discriminate could cut through millennia of speculation. This is the lesson that extends far beyond optics. When two explanations seem equally valid, seek the conditions under which they predict different outcomes. Then test. If no such test exists, acknowledge genuine uncertainty. If such a test exists, perform it. This is how opinion transforms into knowledge. This is how natural philosophy proceeds. And this is what was done. Let sunlight enter a darkened chamber through a small aperture in the window shutter. This is how proper inquiry begins, not with speculation about what light ought to be, but with careful observation of what light does. Let the conditions be controlled, the variables isolated, the phenomena made plain. Let nature speak, and let us attend. The narrow beam of white light falls upon a glass prism. What happens is familiar to anyone who has seen a rainbow or looked through cut crystal. The white beam spreads into a ribbon of colours, each hue taking its place in fixed order. Red on one side, then orange, yellow, green, blue, and violet at the other extreme. The prism has taken white light and produced the spectrum. But what does this demonstrate? If we accept the ancient view, the prism has modified or stained the light, imposing colours upon it through some property of the glass. The colours did not exist before. They were created by the encounter. If we consider the alternative, the view that will prove correct, the prism has separated what was already present. The white light was never simple. It was always a mixture of differently coloured rays, travelling together so intimately that the eye perceived only their blended sum. The prism, by bending each colour at a slightly different angle, has drawn apart what was always distinct. The first prism cannot decide between these views. Both predict the spectrum equally well. Now comes the crucial trial. Isolate a single colour from the spectrum. Place a second board with a small aperture so that only red light, and red light alone, can pass through, leaving all other colours blocked. You now have a beam of pure red, separated from its spectral companions, ready for the decisive test. Direct this red beam through a second prism. If the staining theory is correct, this second prism should modify the red light, just as the first prism modified the white. If prisms impose colour on light, then a prism encountering red should impose further change, darkening it perhaps, or shifting it toward orange or some other hue. There is no reason why staining should occur only once. If glass transforms light, more glass should transform it more. But if colour is intrinsic to rays, if red light carries its colour immutably within itself, then no prism can change it. The red will bend, certainly. It will refract at its characteristic angle, but it will emerge red, unchanged in hue, because its colour is not something imposed from outside, but something belonging to its very nature. The second prism is the question posed to nature. Is colour created or revealed? The answer is decisive. The red ray emerges red, unaltered, unchanged in hue despite passing through glass that should, according to the old theory, have stained it further. It bends at the angle appropriate to red light, less sharply than blue would bend, less sharply than violet, but its colour is immutable. Pass it through a third prism, a fourth, a 10th, the red remains red. One experiment overthrows 2,000 years of speculation. But wait, one demonstration, however striking, might be anomaly or error. Let us proceed more carefully. Let the method prove itself through systematic application. Repeat the experiment with blue light isolated from the spectrum. Direct it through the second prism. The blue remains blue, bent at its characteristic angle, more sharply than red, but unchanged in colour. Repeat with green. The green persists. Repeat with every colour the spectrum displays. In every case, the isolated colour passes through additional prisms without transformation. Each ray carries its colour immutably, its hue determined not by the glass it encounters, but by its own intrinsic nature. This is demonstration. This is proof. But the investigation is not yet complete. If white light is truly composed of these coloured rays, then recombining them should restore whiteness. Analysis has separated the components. Synthesis should reunite them. And so it does. Take the dispersed spectrum and pass it through a lens that gathers the separated colours back together. As the rays converge, the colours blend, and white light returns. What was analysed has been synthesized. What was separated has been recombined. The circle closes. This completes the case. White light is not simple, but compound. It is a mixture of rays, each possessing its own colour, its own degree of refrangibility, its own angle of bending when passing through glass or water or any transparent medium. Red bends least, violet most, and the other colours fall between in fixed order. The prism does not create colour. The prism reveals it. The error of 2 millennia was not idle foolishness. It was the natural conclusion of observation, unguided by crucial experiment. Men saw colours emerge from colourless seeming light and inferred creation, where they should have suspected separation. Their senses deceived them, not through malice, but through limitation. The eye cannot distinguish the individual rays within white light. It perceives only their blended effect. Only the prism, by treating each ray according to its distinct refrangibility, exposes the composition that was always present. And now consider what this teaches about method. The crucial experiment succeeds not by accumulating more observations of the same kind, but by designing an observation whose outcome depends upon which theory is correct. The first prism was ambiguous. Both theories claimed it. The second prism was decisive. Only one theory could survive it. This is how speculation transforms into knowledge. This is how natural philosophy acquires the certainty that mere opinion can never possess. When two explanations account equally well for what you observe, do not choose between them by preference or tradition or the authority of ancient names. Find the conditions under which they predict differently and let phenomena decide. The method that exposed the truth about light is the method that orders all genuine inquiry into nature. It works wherever it can be applied, and it has been applied far beyond optics, to mechanics, to astronomy, to the motions of heaven and earth, always with the same result. Nature yields her secrets to those who ask the right questions in the right way. The principle is established. White light is mixture. Colour is property of rays, not imposition of media. But understanding has barely begun. How do these colours actually behave? Why do surfaces appear as they do? How does the eye perceive mixture as unity? The mechanics underlying the principle demand investigation. Look around you at the coloured world, the red binding of a book, the green of a summer leaf, the blue of fine cloth, the yellow of ripened fruit, the infinite variety of hues that nature and artifice display. Every surface you see presents its colour, as though that colour belonged to it, as though the book were red in itself, as though the leaf possessed greenness as an intrinsic property. This is how we speak. The apple is red. The sky is blue. We attribute colours to objects as we attribute weight or size, as though colour were a quality the thing carries with it wherever it goes. But this is precisely backwards. Surfaces do not possess colours. Surfaces select colours from the mixture of light that illuminates them. A red cloth does not generate redness. It reflects red rays while absorbing orange, yellow, green, blue, and violet. What reaches your eye is not the cloth's creation, but the cloth's choice, the surviving portion of a mixture, the rays that escaped absorption. And therefore the colour you see depends not on the cloth alone, but on the light falling upon it. Consider a merchant shop where fine fabrics are displayed. By daylight, streaming through the windows, a particular cloth appears a vivid crimson. The customer admires it, imagines it made into a garment, prepares to purchase. But as afternoon fades and candles are lit, the same cloth appears different. The crimson shifts toward orange, or brownish red, or some hue not quite what it was before. Has the fabric changed? Has some property of the cloth altered between noon and evening? It has not. The cloth is identical. What has changed is the light. Sunlight contains all colours in generous proportion. Candlelight contains proportionally more red and orange rays, fewer blue and violet. The cloth can only reflect what falls upon it. When the available light shifts, the available rays for reflection shift, and with them, the appearance. This is not trick of the light. This is truth of the light. Now extend the principle further. Imagine illuminating that same red cloth with pure blue light, light that contains no red rays whatsoever. What would you see? You would see darkness, near black. The cloth cannot reflect what is not present. Its nature is to select red from the mixture. If no red is offered, nothing is selected. The cloth appears almost black because it absorbs the blue rays and has no others to reflect. Its redness was never a thing it possessed, but only a description of which rays it permits to escape. This transforms how you must understand every coloured surface you encounter. The white page reflects all colours together, preserving the mixture. This is why white appears neutral. It favours no component, selecting all equally. The black surface absorbs all colours, reflecting none. This is why black appears as absence. Nothing returns to the eye. Every colour between these extremes represents a different pattern of selection. Blue surfaces absorb red and yellow and green while reflecting blue. Yellow surfaces absorb blue and violet while reflecting yellow, and some red and green that combined produce the sensation of yellow. The coloured world is not a collection of coloured objects, but a continuous display of selective reflection, of surfaces interacting with illumination, of rays surviving their encounter with matter. Whence it follows that what we call colour names not one thing, but an interaction. The red is in the rays. The selection is in the cloth. The experience is in the eye. Three elements combine, and none alone determines what we perceive. This explains phenomena that otherwise seem puzzling. Why do colours appear differently by firelight than by daylight? Because fire emits a mixture weighted toward red and orange, offering less blue for blue surfaces to reflect. Why do coloured fabrics sometimes appear to match in the shop but clash when brought home? Because the shop's illumination differed from the home's, and surfaces that selected similar rays under one light reveal their different compositions under another. Why do painters labour so carefully to match colours, only to find their work appearing differently in galleries than in studios? Because the light changed, and with it, the available rays, and with the available rays, the colour sensations produced. The practical implications are immediate. When selecting pigments or fabrics for purposes where colour must remain consistent, examine them under multiple illuminations. What your eye reports as identical in one light may diverge in another, not because your eye has failed, but because the surfaces, though appearing alike, are selecting differently from differently constituted mixtures. No illumination is privileged. Daylight is merely familiar, not uniquely truthful. The colours you see by sunlight are no more real than the colours you see by candle. Both are genuine interactions between surface properties and incident rays. Neither reveals the object's true colour, because objects have no true colour apart from their interaction with light. This is a profound shift. We speak as though colours belong to things. We must learn to understand that colours belong to relationships between light and surface and perceiver. Here is an exercise for observation. Take a piece of coloured fabric, any colour will serve, and examine it in direct sunlight near a window. Note its hue, its intensity, its character, then carry it into shadow, into the interior of the room, and observe it again. Finally, if candles are available, observe it by candlelight. The fabric remains identical. Your perception shifts, and this shift reveals the truth. You were never seeing the fabric alone, but always the fabric's interaction with whatever rays fell upon it. The colour was never in the cloth. The colour was in the meeting of cloth and light. Yet there is more to this story. The light falls upon the surface selects and reflects certain rays. But what receives these rays? What transforms them into the experience of colour? The eye, the perceiver, the instrument of vision that summarises where the prism analyses. And this instrument has properties of its own, properties that further complicate our understanding of what we mean when we speak of colour at all. Here is a fact that seems impossible until you grasp its implications. The eye cannot distinguish between a single pure yellow ray and a mixture of red and green rays. Present to the eye, a beam of spectral yellow, true yellow, isolated from the prismatic spectrum, composed of rays all of identical nature. Then present a carefully proportioned mixture of red and green rays, blended together. To the eye, these appear identical. Both register as the same yellow, but they are not the same. The prism would reveal the difference instantly. Pass the spectral yellow through a prism, and it bends at its characteristic angle, emerging unchanged, still yellow, still uncompounded. Pass the mixture through a prism, and it separates. Red bends to one position, green to another. What appeared to the eye as one colour is revealed by the prism as two. The eye blends what the prism distinguishes. This is not a defect of vision. This is the eye's nature, its function, its design. The eye evolved to serve practical purposes, recognizing objects, distinguishing surfaces, navigating the world. For these purposes, it matters little whether yellow light is simple or compound. What matters is the rapid identification of surfaces by their appearance. The eye summarizes because summary serves survival. But summary is not analysis. The eye's report tells you how light affects your perception, not how light is composed. Consider what this means for your understanding of white light. White light appears white, uniform, undifferentiated, simple. Not because it is simple, but because the eye integrates all its spectral components into a single blended sensation. Every colour present, none distinguished. The eye cannot perceive the composition that the prism reveals. It can only report the combined effect. This is why the composition of white light remained hidden for millennia. The instrument of detection, the eye, was precisely what concealed the truth. Men observed white light and saw uniformity because the eye presents uniformity. Only when the prism subjected light to analysis that the eye could not perform did the hidden composition become manifest. And therefore, every time you see white, you see a blend your eye cannot decompose. Every time you see any colour, you see your eye's summary of the rays reaching it, which may be simple or may be compound, and you cannot tell the difference. This phenomenon, different physical compositions producing identical colour sensations, extends throughout the spectrum. Two surfaces may appear perfectly matched under one illumination, both appearing the same green, while actually reflecting quite different combinations of rays. Change the illumination, and suddenly they diverge. One shifts toward yellow, the other toward blue, revealing that their apparent identity was the eye's failure to distinguish, not genuine sameness. Dyers and painters have known this practically for centuries. Colours that match by candlelight may clash by daylight. Now you understand why. The surfaces were never truly identical. They merely produced identical sensations under particular conditions. When conditions changed, the physical difference asserted itself. This places the observer firmly within the observation. Colour is not purely objective, not purely a property of rays alone. Colour involves the perceiver, the instrument of perception, the particular way that instrument summarizes its input. Different eyes, different species, perhaps different individuals may summarize differently. What appears as one colour to you may appear otherwise to another perceiver whose eye integrates according to different principles. We stand, therefore, at a remarkable pass. Light carries colour as an intrinsic property of its rays. This is demonstrated by the prism experiments that show each ray maintaining its colour through any number of refractions. Surfaces select from the mixture of illumination according to their material properties. This explains why colours change under different lights, and the eye summarizes what it receives according to its own nature. This explains why physically different compositions can produce identical sensations. Three elements combine to produce what we experience as colour: the light, the surface, the perceiver. None alone determines the outcome. All three interact. And the interaction is what we mean when we say, "I see red," or "that object is green." This is humbling. We imagine ourselves perceiving the world directly, as though our eyes were clear windows giving unmediated access to reality. But eyes are not windows. Eyes are instruments, limited, summarizing, interpreting. They serve practical purposes admirably, but they do not reveal physical truth. For that, we need instruments of analysis, prisms, experiments, careful variation of conditions. Here is how one investigator tested the limits of color perception in ways that reveal the eye's operation. Press gently on the closed eyelid, not hard enough to harm, but enough to create pressure on the eye. Colors appear, rings of light, patterns, hues that exist nowhere in the external world, but only as the eye's response to mechanical stimulation. This demonstrates that color sensation can be produced without colored light, that the eye generates the experience through its own operation, not merely through passive reception. Pressure creates color. The eye is not a transparent window, but an active participant in constructing what we perceive. Even more strikingly, take a thin needle, a bodkin, and carefully position it beside the eye, pressing gently at the edge of the socket, not into the eye, but beside it, creating pressure from an unusual angle. Strange colors appear, distortions of vision, experiences that reveal how mechanical influence on the organ of sight affects what we claim to see. These are not idle curiosities. They demonstrate that color, as we experience it, is a product of the eye's operation, not merely a report of external reality, but an interpretation constructed by the perceiving organ. The rays carry their properties, the surfaces select, but the final experience arises within. What follows from all this? You must hold your perceptions more lightly. What you see is real as experience, but it may not correspond simply to what exists. The white light appears simple, though it is compound. The matched colors appear identical, though they are different. The pressed eye produces colors from darkness. Perception interprets. It does not merely transmit. But this is not cause for despair. Rather, it is the beginning of genuine understanding. Once you recognize the eye's limitations, you can design instruments to transcend them. The prism extends vision beyond what the eye naturally achieves. The microscope extends vision to scales the eye cannot reach. Every instrument of natural philosophy represents human recognition of perceptual limits and human ingenuity in overcoming them. The eye blends where the prism separates. Both report truly, the eye summarizing for practical purposes, the prism analyzing for philosophical ones. Neither is wrong. Both are limited. And understanding both allows us to navigate between sensation and reality with greater confidence. Yet there is more to discover. Colors appear even where no colored substance exists, in soap bubbles, oil films, the shimmering wings of certain insects. If color is selective reflection from surfaces, what creates color where no pigment is present? The properties of light extend beyond what we have yet examined, and examining them will reveal that color is even more fundamental than we have supposed, that it belongs to light itself in ways that matter independent of any surface or any pigment at all. Watch a soap bubble form and float in sunlight. As it drifts, Colours swirl across its surface, bands of pink and green and gold that flow and shift, merge and separate, intensify and fade. The colours are vivid, unmistakable, beautiful, and they exist in no pigment, no dye, no coloured substance whatsoever. The bubble is merely soap and water. Its thin film contains nothing that should produce colour by any principle we have yet examined. There is no selective reflection here in the ordinary sense, no material absorbing certain rays and reflecting others. The film is transparent, light passes through it, and yet, colour. Brilliant, shifting, undeniable colour. How can this be? Here is the phenomenon that reveals colour's deepest nature. Colour can arise from pure geometry, from the arrangement of surfaces and the behaviour of light rays, without any coloured matter at all. The bubble demonstrates that colour belongs to light itself in ways more fundamental than selective reflection, more basic than the interaction of rays with pigments. Consider what happens at that thin film of soap. Light strikes the outer surface, and some reflects back toward your eye. But light also enters the film, passes through its thickness, strikes the inner surface, and reflects from there as well. Now you have two sets of reflected rays, one from the front surface, one from the back. These rays travel slightly different distances. The ray reflecting from the back surface has traversed the film's thickness twice, once entering, once exiting, while the ray from the front surface has not entered at all. This difference in path creates a difference in how the rays combine when they reach your eye. Light behaves in ways that depend upon this path difference. When rays of certain colours travel paths that cause them to reinforce one another, those colours appear bright. When rays of other colours travel paths that cause them to cancel, those colours disappear. The result is that some colours survive to reach your eye while others are extinguished, and you see only the survivors. Whence it follows that the colour you perceive depends entirely upon the thickness of the film at each point. Where the film is slightly thicker, one set of colours reinforces and another cancels. Where the film is slightly thinner, different colours survive. As the bubble drains and its film thins unevenly, the colours shift and flow, not because any pigment moves, but because the geometry changes. This is colour created by arrangement alone. Pure optical effect. No dye, no pigment, no coloured substance, and the bubble is not alone in demonstrating this principle. Consider oil floating on water after a rain. The thin film of oil produces the same effect, rainbow colours spreading across the puddle, shifting as you change your viewing angle, arising from nothing more than the geometry of light encountering a transparent layer of precise thickness. Consider the wings of certain insects, the tail feathers of peacocks, the shimmering scales of fish. These surfaces display colours that shift and change as the angle of view changes, colours more brilliant than any pigment could produce. This is not the colour of dyes, but the colour of structure, microscopic architectures of transparent layers that select colours through geometry rather than chemistry. The peacock's display is not painted, it is constructed. The feather's microscopic structure creates the conditions for certain colours to reinforce and others to cancel, change the angle, change the path lengths, change the colours that survive. This is why the peacock shimmers, why its colours seem to flow and shift as the bird moves. No pigment produces such effects, only structure can, from which it appears that colour is more fundamental than matter. Colour belongs to light itself, to the rays and their intrinsic properties, and can manifest through multiple mechanisms. Selective reflection is one mechanism, surfaces absorbing some rays and reflecting others. But structural colour is another. Arrangements of transparent materials selecting colours through the geometry of path lengths and reinforcement. Both are real. Both produce genuine colour sensation, and the eye cannot distinguish between them. When you see a red flower, you likely witness selective reflection, pigments in the petals absorbing blue and green while reflecting red. When you see a soap bubble swirling pink, you witness structural colour, geometry selecting wavelengths without any pigment at all. Both appear as colour. Both are colour. But their mechanisms are entirely different. Here is an exercise for observation. If you can produce soap bubbles, or observe oil on wet pavement, or examine a compact surface of any thin transparent film, watch carefully how the colours behave. Notice that they move. Notice that they depend on angle. Notice that different regions show different colours simultaneously, and that these regions shift as the film drains or as you change position. This movement, this angle dependence, this shifting, these are the signatures of structural colour. Pigment colours are stable. They look much the same from any angle, under any illumination that contains the relevant rays. Structural colours dance. They reveal their geometric origin through their geometric behaviour. And this reveals something profound about what we've been calling colour all along. We began by understanding that white light is compound, a mixture of rays, each carrying its own colour immutably. We proceeded to understand that surfaces select from this mixture through absorption and reflection. We recognize that the eye summarizes what it receives, blending where the prism distinguishes. Now we see that colour can manifest through yet another mechanism, through pure arrangement, through the geometry of transparent layers, through the behaviour of light itself, independent of any coloured substance. Colour is not one thing. Colour is the name we give to a class of phenomena, all involving light's intrinsic properties, but manifesting through different physical mechanisms. The rainbow's colour arises from refraction separating the spectrum. The cloth's colour arises from selective absorption. The bubble's colour arises from thin film interference. All produce the experience we call colour. All operate through different principles. And yet, and here is the unity beneath the variety, all depend upon the same fundamental truth. Light carries colour intrinsically, as a property of its rays, and these properties manifest whenever conditions allow them to be distinguished. The prism distinguishes by refraction. The pigmented surface distinguishes by absorption. The thin film distinguishes by interference. But in every case, what is distinguished was always present. The colour was always there, in the light, waiting for conditions that would reveal it. This is the deeper lesson. Colour does not arise from nowhere. It is not created by matter or geometry from nothing. Colour emerges when conditions separate or select from what light already contains. The mechanisms differ. The underlying reality is one. The soap bubble becomes a window into light's fundamental nature. In its swirling colours, you witness not the bubble's properties, but light's properties, the intrinsic characteristics of rays, made visible through geometric conditions that allow some to reinforce and others to cancel. What seems most delicate and ephemeral, the shimmer on a soap bubble, reveals what is most fundamental and permanent. That light is not simple, that colour is intrinsic, that the world of appearances arises from underlying realities that careful investigation can expose. The pieces of understanding we have gathered, composition, selective reflection, the summarizing eye, structural colour, now await integration. They are not isolated facts, but aspects of a coherent whole. And seeing that whole, will complete our transformation from confused observers to genuine comprehenders of light. Stand back now and consider what has been revealed. White light, which appears uniform and simple, is in truth a compound of differently coloured rays. Each ray carries its colour immutably, bending at its characteristic angle when passing through glass or water, maintaining its nature through any number of refractions. The prism separates what was always distinct. Recombination restores the white that separation dissolved. Surfaces appear coloured because they select from the mixture of illumination, absorbing some rays while reflecting others. The colour you see is not the surface's possession, but the interaction of surface properties with incident light, an interaction that changes when illumination changes. The eye perceives this selection and summarizes it into sensation. Different physical compositions can produce identical color experiences. The eye blends where careful analysis would distinguish. Perception is interpretation, not transparent transmission. And color can arise even without colored matter, through the geometry of thin films and structured surfaces, through conditions that cause some rays to reinforce while others cancel. Color belongs to light itself, fundamental and intrinsic, capable of manifesting through multiple mechanisms. These are the pieces. But what is the whole? Here is the unity that binds them. Nature speaks one language, and that language is mathematical order. The same principles that govern light, govern motion, govern celestial mechanics, govern the fall of stones and the flight of arrows. The method that exposed light's composition is the method that orders all genuine inquiry into nature's workings. Consider celestial mechanics. The planets appear to wander erratically against the fixed stars, hence their ancient name, wanderers. For millennia, astronomers contrived elaborate systems of circles upon circles, epicycles and equants and deferents, trying to account for these apparent irregularities. The schemes grew ever more complex as observations accumulated, each new difficulty requiring new adjustments. Yet when the correct principle was found, that bodies attract one another with force proportional to their masses and inversely proportional to the square of the distance between them, the apparent complexity resolved into elegant simplicity. One law, expressed mathematically, predicted the motions of all planets with precision. What seemed to require endless adjustment followed from a single principle. The parallel to light is exact. For 2,000 years, the phenomena of colour seemed to require special explanations multiplied without end. The rainbow required one account, coloured glass another, the colours of objects a third. Each phenomenon was treated as if unique, demanding its own theory, its own speculative mechanism. But when the fundamental truth was grasped, that white light is compound and colours are intrinsic to rays, the apparent complexity resolved. One principle explained the rainbow and the prism and the coloured cloth and the shifting hues of thin films. The variety of phenomena arose not from multiple causes, but from a single underlying reality, manifesting under different conditions. This is not coincidence. This is nature's way. Diverse phenomena follow from few principles. Apparent complexity arises from simple laws operating under varied conditions. The task of natural philosophy is to discover those underlying principles, to see through the variety of appearances to the unity beneath. And the method for doing so is the same wherever it is applied. Observe phenomena carefully, attending to what actually occurs rather than what tradition claims. Design experiments that discriminate between competing explanations, rather than merely confirming what you already believe. Deduce the implications of proposed principles and test them against further observations. Let nature's answers, not human preferences, determine what is accepted as true. The prism is one analytical instrument. Mathematics is another. Controlled variation of conditions is a third. All serve the same purpose: separating what is confounded, measuring what is separated, deducing what measurement reveals. What worked for light works for gravity. What works for gravity works for the tides, for projectile motion, for the behavior of pendulums, for every domain where careful inquiry can be applied. The methods generalize. The unity of nature guarantees that what works in one domain will work in others. Whence it follows that genuine understanding in any domain equips you for understanding in all domains. The habits of thought that expose light's composition, questioning assumptions, designing discriminating tests, attending to phenomena rather than speculation, are the same habits that illuminate celestial mechanics, that clarify the behavior of fluids, that reveal the laws governing all natural motion. This is not merely philosophical sentiment, it is practical truth. The navigator who understands gravitational attraction can calculate tides and predict the moon's position for determining longitude. The gunner who understands projectile motion can aim accurately at distances where intuition fails. The lens grinder who understands refraction can design instruments that extend human vision beyond natural limits. Method is not separate from application. Method is what makes reliable application possible. And consider further that diverse phenomena obey common laws is itself a fact requiring explanation. Why should the same mathematics describe the moon's orbit and the apple's fall? Why should the same principles govern the refraction of red and violet rays? Why should nature admit of unified understanding at all? The uniformity cannot be accident. The elegance of this arrangement, few principles generating infinite variety, mathematical order pervading all phenomena, understanding available to minds that attend carefully, demands explanation. It points beyond mere mechanism to something deeper, an architecture, a design, a wisdom expressing itself through the workings of the natural world. Those who see only isolated facts miss the pattern. Those who see the pattern recognize that they stand before something vast, a cosmos ordered by intelligence, comprehensible to intelligence, inviting further investigation without limit. This is the unified vision, not merely facts about light, but understanding of how facts cohere, not merely knowledge of one domain, but equipment for all domains, not merely answers to particular questions, but a method that generates answers wherever questions arise. The scattered pieces reveal their pattern. Individual insights integrate into coherent whole, and the whole is greater than any sum. It is a way of seeing, a mode of understanding, a permanent enhancement of the mind's capacity to comprehend what is. Yet understanding that remains merely intellectual has not completed its work. Knowledge must become perception. Principles must become the lens through which we see the everyday world transformed. This is the final stage of the journey, not merely knowing these truths, but seeing through them, so that the ordinary world reveals its extraordinary nature, continuously, without effort, as the natural consequence of genuine comprehension. Return now to the rainbow. You have seen rainbows before, perhaps many times. They appeared after storms, arcing across the sky, displaying their colours against grey clouds or above rain-soaked fields. You looked, you admired, you perhaps felt wonder at their beauty. But what did you see? Before this journey, the rainbow was mystery. Where did those colours come from? How did the grey light become a spectrum? The bow seemed magical, inexplicable, a phenomenon demanding explanation but receiving only wonder. Look now with different eyes. The water droplets suspended in the air act as countless tiny prisms. Sunlight enters each droplet, refracts at the first surface, reflects off the back, and refracts again as it exits. And with each refraction, the principle you now understand applies. Rays of different colours bend at different angles. Red bends least, violet most, the other colours falling between. From any single droplet, only one colour reaches your eye, the colour whose refracted path happens to aim precisely at where you stand. But millions of droplets hang in the air at different angles, and from each angle a different colour arrives. The droplets at one angle send red, those at another send orange, those at another send yellow. The arc of the rainbow traces the geometry of refraction across the sky. The rainbow does not create colour. The rainbow displays the composition of sunlight, separating what was always distinct, spreading across the heavens the same spectrum that a prism spreads across a darkened chamber. Has the rainbow changed? It has not. Has your perception changed? It has transformed entirely. What was mysterious is now demonstration. What provoked only wonder now provokes understanding, and wonder together. The bow no longer appears as magic, but as mathematics made visible, the laws of refraction written across the sky in light. This is what genuine comprehension does. It does not diminish wonder, it deepens it. Mystery that resolves into understanding is more satisfying than mystery that remains opaque. The rainbow is more marvelous as evidence of light's composition than it ever was as unexplained beauty. And this transformation extends throughout your visual environment. Look at the white page before you, or any white surface within view. You now know that its whiteness is not simple. The surface reflects all rays together, preserving the compound mixture of sunlight, sending to your eye a blend your eye cannot decompose. The white is summary, not simplicity. Hidden within it is the entire spectrum, all colours present, none distinguished by your perceiving organ, but all genuinely there. Look at a coloured object, the red binding of a book, the blue of a garment, the green of a leaf. You now see it differently. The surface does not possess its colour. It selects its colour from the available illumination. The red book reflects red rays and absorbs the others. The blue cloth reflects blue rays and absorbs the others. What reaches your eye is not the object's property, but the object's choice, the rays that survived, the portion of the mixture that escaped absorption. Look at shadows and notice what you may never have noticed before. Shadows have colour. They are not merely dark, but subtly hued, because reflected light from surrounding surfaces illuminates them, and that reflected light carries the colours of the surfaces it has bounced from. A shadow cast near a red wall will be touched with red. A shadow cast on green grass will contain green. Shadows are not absence of light, but presence of different light, and different light means different colour. Look at candle flame and understand why it shifts the colours of objects. The flame emits light proportionally richer in red and orange, poorer in blue and violet. Objects illuminated by candlelight receive a different mixture than objects illuminated by sunlight, and therefore reflect different selections, and therefore appear different. This is not illusion. This is truth. The colour you see is always the interaction of surface properties with available illumination. These observations were always available to you. The shadows always had colour. The white surfaces always hid the spectrum. The candle always shifted the hues of everything it lit. You could have seen these things before, but you did not see them, because you did not know to look for them. Understanding has made visible what ignorance concealed. This is the transformation. Not a change in the world, but a change in you. The world is as it was. Your eyes function as they always functioned. But your comprehension has changed what your perception means, has revealed significance where before there was mere appearance. And the transformation is permanent. You cannot now see white light as you once did, as obviously pure, as self-evidently simple. You know too much. The knowledge has become part of how you see. This is the goal of all genuine teaching, not information stored in memory, but perception permanently altered, not facts that might be forgotten, but understanding that becomes the lens through which new experience is interpreted. You do not remember the principles you have learned, you see through them. They have become you. Here is an exercise for confirming the transformation. Take a familiar object, a piece of fruit, a book, a garment, and observe it under different illuminations. Direct sunlight, shade, candlelight if available. Note how its colour shifts while its substance remains unchanged. You are witnessing the principle made manifest. Colour as interaction, appearance as function of light and surface together. Before this journey, such shifts might have puzzled you or passed unnoticed. Now you understand them. Now you see them as evidence of truths you comprehend. The puzzle has become a demonstration. The unnoticed has become significant. And this extends beyond light into every domain where you have learned to see properly. The person who understands gravity sees falling objects differently, not as mystery, but as evidence of attraction operating according to mathematical law. The person who understands celestial mechanics sees the moon differently, not as a wandering lamp, but as a body perpetually falling around the earth, held in orbit by the same force that holds apples to trees. The person who understands refraction sees every lens, every glass of water, every crystal differently, as an instrument revealing properties of light, as opportunity for observation and demonstration. Understanding transforms perception. This is not metaphor, but fact. And the transformation, once achieved, invites extension. If the principles revealed about light extend to other domains, if the method that exposed light's composition can expose truths elsewhere, then every apparent simplicity becomes a question. What else that seems simple might, upon proper investigation, reveal hidden composition? What other certainties might yield, under experimental pressure, to deeper truths? The ocean of truth stretches before us. We have found a few pebbles on the shore. A child walks along the shore and finds a smooth pebble. It delights her, the feel of water-worn stone against her palm, the patterns of colour in its surface, the satisfying weight. She puts it in her pocket and continues, seeking another and another. Each pebble found is a small triumph. The beach is full of treasures. The natural philosopher walks the same shore and finds the same pebble. But he sees more. He sees in its smoothness the evidence of ages, waves grinding stone against stone, year upon year, century upon century, shaping rough rock into this polished form. He sees in its colours the minerals from which it was composed, the geological forces that created it, the history of the earth written in miniature. The same pebble, different understanding, different perception. Does knowledge diminish the pebble? Does understanding reduce it to mere mechanism, robbing it of wonder? It does not. The philosopher delights more, not less. His wonder has not been replaced by explanation. His wonder has been deepened by it. The pebble becomes more marvellous as its history is comprehended, more significant as its place in nature's order is understood. This is what awaits the mind that inquires carefully. Not the death of wonder, but its transformation into something richer. Mystery that remains forever opaque offers only frustration. Mystery that gradually yields to investigation offers endless reward. And here is the truth that completes our journey. The ocean of truth is inexhaustible. Every discovery opens new territory for inquiry. The composition of white light, once understood, raises questions about the nature of the rays themselves. What are these corpuscles that carry colour? How do they travel from sun to eye? What determines their different properties? The behaviour of thin films, once grasped, invites investigation into the precise conditions that cause reinforcement or cancellation. Every answered question reveals further questions. Every pebble found illuminates how many pebbles remain unfound. This is not cause for despair. This is cause for wonder and for courage. The ocean is infinite. The shore is infinite. The pebbles are numberless. A lifetime of investigation would not exhaust the smallest fraction of what remains to be discovered. This vastness does not diminish what we have learned. It illuminates its significance. Each truth found is a truth that was always there, waiting. Each principle discovered is a principle that governs nature, whether we know it or not. In finding these pebbles, we participate in something larger than ourselves, the ongoing revelation of how nature works, the gradual comprehension of the cosmos by minds capable of comprehending. Consider the posture this produces. On one hand, confidence. We know how to investigate. The method that revealed light's composition can be applied wherever it is applicable. Design discriminating experiments. Attend to phenomena rather than speculation. Deduce implications and test them. Let nature's answers determine belief. This method works. It has proven itself in optics, in mechanics, in celestial matters. It will prove itself wherever careful minds employ it. On the other hand, humility. We do not know what investigation will reveal. The conclusions we draw are provisional, subject to revision should new experiments expose our errors. The history of light shows how easily brilliant minds can hold false beliefs for millennia. We must suppose that we too hold false beliefs that future inquiry will expose. Confidence in method must combine with modesty about conclusions. This is not contradiction, but complement. Certainty about how to investigate pairs with uncertainty about what investigation will find. Pride in the pebbles we have gathered pairs with humility before the ocean that remains unexplored. Whence it follows that genuine understanding does not conclude. It commences. The documentary you have attended has not brought you to an ending, but to a beginning. You now possess tools, a method of inquiry, a transformed perception, an understanding that changes how you see. These tools do not complete your work, they equip you to begin it. What else that seems simple might, upon proper investigation, reveal hidden composition? This is not a rhetorical question. It is a research program. Apply the method. Where do you accept appearance without test? Where do you assume simplicity without analysis? Where might a well-designed experiment distinguish between explanations that casual observation conflates? The tools work wherever they can be applied. The world awaits investigation. Consider how much has been revealed from a single inquiry into light, the composition of whiteness, the intrinsic nature of colours, the selective behaviour of surfaces, the summarising operation of the eye, the structural production of colour without pigment, the unity of method across domains, the transformation of understanding into perception. All of this from attending carefully to how light behaves when subjected to prisms. What might attend carefully to other phenomena reveal? What might the behavior of falling bodies tell us about the nature of force? What might the motions of planets tell us about the architecture of the cosmos? What might the properties of matter tell us about the principles governing all substance? The questions extend without limit. The ocean stretches infinite before us. And this is the final truth. The capacity to investigate is itself the greatest gift that understanding provides. You have not merely learned facts about light. You have learned how to learn facts about anything. You have not merely corrected a misconception. You have acquired methods for correcting misconceptions wherever they occur. The tools generalize, the ability extends. What seemed like a specific inquiry, the nature of light and colour, has revealed itself as a general education in how to investigate nature, how to question assumptions, how to design tests that discriminate, how to transform understanding into perception. This is the true inheritance, not a catalogue of truths to be memorized, but a capacity for discovering truths not yet known. Not answers that satisfy inquiry, but methods that enable inquiry. Not the pebbles we have gathered, but the ability to find more. We began with a simple claim. You think you understand light, and you are wrong. You have now seen the error exposed, the truth demonstrated, the principles revealed. White light is compound, a mixture of rays, each carrying its colour immutably, travelling together so intimately that the eye perceives only their blended sum. Colour is intrinsic to rays, not imposed by media. Prisms separate what was always distinct. They do not create what was never there. Surfaces select from the mixture of illumination, absorbing some rays while reflecting others. Colour experience arises from interaction between light and surface and perceiver, not from any single element alone. The eye summarizes where the prism analyzes. Different physical compositions can produce identical colour sensations. Perception interprets, it does not merely transmit. And colour can arise through geometry alone, through thin films and structured surfaces that cause some rays to reinforce while others cancel, demonstrating that colour belongs to light itself, fundamental and intrinsic. These truths, once understood, transform how you see. The rainbow becomes demonstration. The coloured surface becomes evidence. The shadow reveals its hue. The ordinary world displays its principles continuously, without effort, to the eye that knows what to look for. And the method that revealed these truths extends wherever it is applied. Design experiments that discriminate. Let phenomena decide what speculation cannot. Proceed from observation to principle to implication. Test. Verify. Question always. The world is not as it appears, but it is knowable. Method makes knowledge possible. Knowledge transforms perception. And perception, thus transformed, opens upon endless further investigation. The light that illuminates this page contains all colours, hidden in plain sight. What you see as white is compound. What you see as coloured is selection. What you perceive as simple is the eye's summary of complexity beyond its power to distinguish. This was always true. You can now see it. What else is true that you cannot yet see? What other certainties might yield under experimental pressure to deeper truths? What other apparent simplicities might prove, upon proper investigation, to be compositions as intricate as light itself? The ocean of truth lies undiscovered. The shore is infinite. The pebbles are numberless. Go and look.